Okay, now in class we are going to see logarithms. How do we handle logarithms? They are related to indices. We are going to see how you approach them. Okay, a logarithm of a positive number is a power or index to which the base is raised, as simple as that. How do we read these logarithms? So if I have log with a there and b there, it's read as logarithm of a to base b. That's how we read the logarithm. We read it as logarithm of a to base b. This one here. Now let us see laws of logarithms, or some people call them properties. Okay. If we are here to say we have log of a base c plus log of b base c, it's the same as if we are adding them, you get this and you multiply them like that. As simple as that. If you assert this works if the base is the same. What you do? You maintain the base, then you multiply this up here. If you are the base is the same and you're subtracting, you get this divided by that. Then if you have log base of a power n base b, now the same as this power can drop from here to here as you see. Then multiplies the whole of this. When this power, we can drop or raise that power. Then log of a base n, if this and this are the same, then that one is log. It's always a 1. Then log of a base b equaling c is the same as getting this equaling to the base power this, as simple as that. Then these ones are so much for A-level students where we change the base. This one we use it to change the base. You get log of a base b is equal to 1 over log b a. Then log of 1 base a is always 0. Then also this is for higher level. When we change the base, we need to change the base to new base. We introduce the base to the upper, then to the base which was there. This one now works if you are introducing a new base. This one works if you want to change the base up to go down. Then this one if you want a new base. Then if log of a base c is equal to log of b base c, if the bases are the same and these two are equaling, it means that a is always equaling to b. Then a log without a base is always base 10. Now, we apply these properties if the coefficients are 1s. As is 1, 1, 1, then we subtract. That's how we apply those properties. Okay, now evaluate the following. Now these are very easy. You see you have base 2, you have here 14. You ask yourself, can I express 16 in terms of as a base of 2? You go and you prime factorize. So you have 16. Now you use this base by 2, 8, by 2, 4, by 2, 2, then by 2, 1. This is now, instead of our 16 will be the same as 1, 2, 3, 4, 2 power 4. So now, start this with log 2 power 4 base 2. Now, these are the bases, this and this are the same. You will come almost to this power. This works without a power. What do we do? We first remove this power. How do we remove it? This is the property that we use. This power goes there down. So now when this power goes down, I'll be adding 4 log base 2, which will be 4 times. Now we see that the base and this are the same. So see that this and this are the same. So the whole of this is 1, which will be a 4. Is this and this is 1. When I come to this, how do we prime factorize 27 in terms of 3? Be the same as log 3 power 3, 3. 27, if you have to prime factorize it, come there, 27 by 3, 9. By 3, 3. By 3, 1. So that 27 is now the same as 3 power 3. Why? I'm basing on this base. Now I see this is the same, but to apply the other property, I need this power to go off first. So when I pull it down, it will be now 3, now log of 3, base 3. Now we have the same base, and this is the same, it's always 1. So this will be 3, now times 1, which will be 3. When I come to this one, you see 10 and 100. So meaning, this can be the same as our log. 110 is the same as log 10 power 2. Because 100 is the same as 10 power 2. But you always base on the base. Let's to prime factorize this one. So this will be now 2 log 10, which will be 2 times 1, which will be a 2. Now, there's a simple trick I want to give you how you can just get these answers. Now, you always ask yourself, what should I raise to the base to get 16? As simple as that. So, what should you raise to the 2 to get 16? Is that when I get which number should you raise to 2 to get 16? So that if this number is 4, I'll get 16. So if I raise 4 to 2, I'll get 16. I think you see. So you can easily handle this in one step. Which number should we, which power or which base should we raise, or which number should we raise to 3 to get 27? That number is 3. Which number should we raise to 10 to get 100? That number is 2. So now we can, okay, now answer for me this in one step, 5. Log 4, 2. Which number should I raise to 2 to get 4? The answer will be 2. And you are done with that. Even if you have log of 9, 3, which power should you raise to this to get 9? That's power 2. Now, let us answer this in one step. It's a bit technical. Which you have 2, you have 4. If it's not this one is always bigger than this, and you start, you can just press this down on this. It means that what you get is a reciprocal of this. Which power should you raise to 4 to get 2? Now you see that the base is bigger. Now what if it was, which power should you raise to 2 to get 4? That power will be 2. Now 2 is here and this is that. It means they go to the reciprocal. It means that the power should raise to 4 to get 2. So that the square root of 4 is what it is given as 2. But the square root is given as a half. So the answer is a half in one step. As simple as that. So that's you try out. You can try out log. You can try out this log 1010. Which part should you raise to 10 to get 1000? You see that the answer will be 3. So you can do those one numbers in one step. So try out that idea. You will see that life will be very, very easy. Okay. Now when you come to this, we ask that you see. Now we are going to apply these properties. A plus B. The only condition you should make sure that is holding. The base should be the same and the coefficient should be 1 before we multiply or divide. So the base is the same, coefficient 1, coefficient 1. Now we can multiply this 2. So I have now log. We maintain the base. You maintain always the base. Then you get, we are adding, so we multiply 12 times 6. And so this will be now log 3. And multiply there. You get 72. And so this one you can't simplify it. You cannot simplify that anyway. Okay, now we have this. We said that we are missing bases, but we said any number without a base is to base 10. So meaning they are to base 10, but you can do it when you are putting that in mind. So that would be now log of 40, 10. 10. Then coefficient 1, 1, 1. So we can now apply the first add. Log, the base is the same. So now we multiply these two times 50. Then after we shall apply this. So that this when I multiply this, I get 2000. Log 10. This will be 50 times 40. 2000 minus log of 20, 10. Okay, now you see if you are subtracting the base is the same, it means that we are going to apply this property here. If you are subtracting when the base is the same, you divide. You get this divided by that. So now, allow me to write this here. So now this will be giving me log of now, I get this 2000 divided by 20. This will be base 10. Now you see this goes by this one, so it will be, I have 100 base 10. Now here I gave you a simple method. You ask yourself, Which number should I raise to 10 to get 100? The answer is 2. Or you can go through the other way of saying this is log 100, okay, 10 power 2, which we drop the power, we get 2, log 10, 2, and this 1, which will be a 2. But we don't got the answer there in one step. Okay, now this one, we said that we apply the property after the when this is power, when the coefficient of this is 1. So we first remove these ones. Now, if you want to remove, now you work backwards. If you have this, now you take it back like this. So you take this back and you get this. So now, this will give me, now log 5 power 4, 10. When I take it back, then plus log 16, now power half, base 10. Then minus, I also remove this, log 125, 10, the whole now power half. As simple as that. Now start, we have constant 1, then also 1. There we can go. Now, you get to calculate 5 power 4. 5 power 4 is 200. I mean 600. Log of 600, 25, 10. When pressed the calculator. Then this you see that 16 half is a square root. Square root of 16 is a 4. Log 10, 4. Or, if you don't want that, you come and write factors. That 16 is the same as 2 power 4. Like this. But we say 16 is power a half, which will be the same as 2 power a half. We say this multiply, which will be 2 power 2, which will be a 4. So you can also use this idea of indices. Then, here we get the cube root of 125. What's the cube root of 125? You see, this is the cube root. We say 1 over, this is the cube root. Or, you say 125 is equal to 5 power 3. Remember, it has a power. So 125 power a third is the same as 5 power 3 power a third. This and this goes away. So now we'll be having log 5, 10. So now we see you're adding coefficient 1, now we can multiply. So this will be now log 625, now times 4, 10, then minus log 5, 10. So there you get your calculator and you say, I'm getting this as 2500, 10 minus log 5, 10. So instead we are subtracting, what happens? We divide. So if you are subtracting, now we come and we divide them. So this would be now, I get this, I divide by this. Log now of 2500 divided by a 5. Our 5 there. Cross the bracket, base 10. And so we divide by this one, by this 5. So we have log 500 base 5. Now there, you can't compute, you leave it there. Sorry? This is 10. This is 10, and you keep it there. Because they don't need to simplify, so I'll simplify. Now, I'm warning you on mistakes people do. Don't ever cross this and this. Some people may be tempted to. Or, don't ever, some people put here a division sign. You do that, you get your 0, 0. Another thing is, when people reach here, they also feel like they want to ask this and this. You do that, you get your 0, 0. So leave it. If they don't simplify, leave it the way it is there. Anyway, so that's it, members. I wish you well.